Today, there's a lot of excitement around AI agents. We have seen impressive demos of agents that plan, reason, and act across tools. But the real question isn't whether we can build them or not. The real question is what it takes to make an AI agent effective in real world environments. When agents move from demo into production systems, many fall short, not because technology is incapable, but because real world problems are complex, constrained, and interconnected. So instead of focusing on what AI agents are, I want to focus on how they behave in practice when embedded into real world systems. Most real world agent problems share the same core challenges. The first one, they span across multiple systems. Second one, they involve a lot of policies, approvals, and rules. They must fit into existing workflows, and the human should always be in the loop. Because of this, successful agents aren't standalone decision makers. They act like coordination layers, maintaining context, orchestrating actions across systems, enforcing rules, and determining when control needs to be transitioned to a human. A common pattern in real-world agent system is coordinating a sequence of actions across multiple systems while managing state, timing, rules, and exception. This pattern shows up anywhere a single event triggers a multi-step workflow with dependencies. One concrete example of this pattern is onboarding a new employee. Onboarding isn't an easy task. It's a workflow composed of many steps, starting with provisioning, access and entitlements, ordering required resources, scheduling initial activities, assigning required trainings, and tracking them to completion. In this use case, agents don't replace people. It uses context-based signals such as roles, location, and start date to sequence actions across systems, monitor workflow state, and flag deviation from expected behavior. The hard part isn't reasoning, it's reliably orchestrating multiple systems while respecting policy and timing constraints. Another recurring pattern is policy governed action execution, where risk, rules, and access control shape what actions a system is allowed to take. This pattern appears whenever a system is handling incoming requests with very level of sensitivity or impact. IT support is a good representation of this pattern. In this case, agent may process requests such as passwords, software or hardware resources, any requests that come through, ticketing and routing of any requests. Some requests follow a well-defined and low-risk execution path. Others require validation, approval, and sometimes escalations. An effective agent in this case interrupts requests intent, evaluates the applicable policies, automatically executes some of the permitted actions, escalates any ambiguous or high-risk cases. This shows the explicit control boundaries. The system behaves predictably, and humans step in precisely where the rules need them to. In other cases, agents operate inside a well-defined processes where exceptions are the real challenge. This pattern shows up in systems such as invoice processing or order management. In this case, an agent may extract structured data, match it against the existing record, validate it against rules or constraint, or route it for approval, and lastly, update the downstream systems. This is a happy path, which is straightforward. The real complexity lies in handling missing data, mismatched data, or any non standard conditions. Agents add value by consistently handling predictable flows and surfacing only true exception for human reviews. Another important pattern involves triaging and routing large volumes of incoming work. This pattern appears wherever the system needs to prioritize attention under load. A customer service is a great example for this. Here, an agent must analyze and categorize incoming requests, route work to the appropriate teams, and suggests responses based on historical data. Humans still resolve the issues, but agents ensure the priority, context, and routing decisions are applied consistently at scale. The pattern holds regardless of where the work originates. Across all the patterns that we saw, regardless of the domain, the same characteristics apply. A successful AI agents are narrowly scoped, they orchestrate across systems, apply rules and related signals, keep human in the loop, and are designed for integration and not isolation. These systems don't feel like flashy AI features. They feel like well-designed components of a larger architecture. The real power of AI agents isn't the autonomy. It's its alignment with real workflows, limits, and control structures. When agents are designed around coordination, rules, and accountability, they stop being experiments and start operating as reliable components in production systems. That's what it takes to make AI agents work in the real world.